Wanted to get some content besides just sanding because sanding is pretty boring. I've been putting in a couple hours a day. I'm trying to get the buck all faired in. I'll have some more updates on that. But right now I got the bike back in the garage and I'm working on the DCDC unit. I have an AC Delco DCDC that I'm going to try and integrate mechanically somewhere inside this body. But right now it's a little bit difficult. One of the main issues I'm having is the 12 volt system is actually having a sag when I give it throttle, meaning that it drops down below the minimum threshold for running my VCU, which is actually an Arduino with a CAN bus shield. So what I wanted to do was integrate a DC-DC converter so that way I could have constant 12 volts and not have to have an issue with voltage drop and having the bike cut out or anything. That means that this thing has to go somewhere on the bike, and I'm trying to find a good spot to put it. Right now, the top of the battery, when I set it up there, it actually impedes with the body, so that's not going to work. I'm actually pulled out my secondary 12 volt system for the parachute. Maybe I'll relocate that, and I'm trying to fit this down into this area. Might not work, and if need be, I'll try and move it to the back of the bike, but considering the weight load is pretty far back right now, I'd like to put it as far forward as possible so I don't move the CG too far back. So the first way I tried to solve this problem was I actually bought a DC-DC converter, but it was 72 volt, and this is just an Amazon special. And in order to get 72 volts, I was kind of tapping the pack at a half point across the manual service disconnect. This was leading to some sort of pack imbalance because I was only pulling 72 volts. So portion of the full pack voltage is being grabbed to do a DC conversion. Now this worked great in keeping the 12 volts stable, and I felt like imbalance was fine as long as I kept the pack balanced prior to each run. The main issue I have with this is it shares the 12 volt ground with your high voltage ground reference. So that meant that even right now, the chassis is connected to some point on the battery, leaving a voltage across the chassis. I actually found that out by kind of getting a little bit of a zap, and that was a bit of a surprise, and that's because this is a non-isolated DC converter. We moved to the AC Delco version, which is a much larger version, more than I need electrically, but it has an isolated 12 volt ground from the high voltage pole. This also takes 350 volts and converts it down to 12 volts and can do, I think, up to 50 amps, which is totally unnecessary. I need maybe 5 amps, 10 amps max. So this is much bigger, but this is about the smallest one I could find on the market. I'm going to remove this piece and make the bike a little bit safer because right now the chassis is actually connected to somewhere inside the battery pack, and that is not good. Look at that. Just fits. So I'm going to make some steel mounts to mount it to here. Okay, so I didn't like the fit. I thought I was going to make something for it, but I ended up going on DigiKey and I found this guy, which is 20 amps. This is 50. This is 20. I'm assuming this one has like 3 of these in there or something, and a cooling system and a CAN bus controller. But this one is just dumb. It sees high voltage. It puts out 12 volts, 20 amps worth. So it's perfect. I'm going to make a small enclosure for this, get some wires out of it, and then we'll go from there. So if I get up to my charge port, I just get the wire shoved in there for right now. It's coming into my high voltage lead. If this is correct, this should show 12 volts. I'm gonna go ahead and turn on the high voltage. If it's not correct, we'll release the magic smoke. If it's not correct, we'll release the magic smoke. Sick. Okay, what do I do with that? Got everything all wired up, got everything all attached, and I'm gonna turn it on, test it out. I already did kind of a rough plug and play to see if everything would work, and the first time I did it, it didn't go so well. So make sure you double check the wiring diagrams. I ended up just putting the 12 volt sensing to the high voltage and it blew this thing up. But I did have a fuse in line, blew the fuse, blew the part, 200 bucks down the drain. Live and learn. But now everything works good, so let's flip it on. We'll go through the switches. The main point I wanted to do with this is I didn't want this DC-DC to turn on until I turned on the main ignition, so I hooked up post contactors. So that way when I turn the contactors on, there's actually a pre-charge circuit, so there's no inrush current in there as well, which is great. And it will only run when the bike is in the on position, which is cool. So. Yeah, success. So now we've eliminated that big piece I was going to put on there. We've solved the issue of the voltage drop that I was having, and we can move on to some other more critical things like this. $150, $180, $200, $220, $230.
I smell it now. Yeah, there it hit now.
Coming soon.